Hello, I'd like to speak to you about some work at Mayo Clinic on using FHIR and in RDF and shape expressions to validate that FHIR. I'll start out with a quick introduction to FHIR, how it's defined and how it's represented. Then I will present a schema language for FHIR called shape expressions or ShEx, and finally give a quick idea of how we're using this for agile development of cancer data exchange formats. FHIR is fast healthcare interoperability resource. It consists of around 120 resources. These are things like patient, procedure, observation, etc. It has some APIs in both in REST and SOAP. It's under the HL7 is developing this with an open agile development process on GitHub, and FHIR has its own specific FHIR-specific meta model, which comes with its own representations and tooling. The FHIR homepage at hl7.org/FHIR provides you with a link to the with the status, which is here we see it's DSTU2, but it also brings you to a version directory, which brings you to the GitHub repo, where we can explore the 120 resources that I just mentioned. Let's look at the ever popular clinical observation. The observation resource includes a hierarchical view of an observation. This says, for instance, that an observation has 0 or more identifiers. Note the 0 to star. Exactly one status of type code, and for instance an observation.subject, which is a reference to either a patient, a group, a device, or a location. Resources can be viewed in this hierarchy or in a UML diagram or as one of the documentation by example templates. For instance, here we see XML, JSON, or most recently FHIR RDF as represented in Turtle. The examples, the FHIR data FHIR site is full of examples. It's very much learned by example. Examples are available in the same formats as the templates. So for instance, here's a FHIR observation that's expressed in RDF's Turtle language. Here we see that it has a status of final and a category with a coding of vital signs from the HL7 FHIR coding system for that. So where are we with FHIR? It's approaching stable. We're following some principles like lossless round tripping between formats, and to help ensure that we have valid data, we're using a schema language designed for RDF. There are links to the various schema languages, including shape expressions, the one for RDF, at the bottom of the template tabs. And to give you a quick idea of what that looks like, on the left is a hierarchical view of an observation, and on the right is its ShEx equivalent. So we see, for instance, the identifier is right here and the status is below it, etc. So to give you a quick idea of how shape expressions works, I've preloaded the FHIR observation with actually an error. So if we're getting a red error right here that says that it was expecting a domain resource text, and in fact inside of that it was expecting a narrative status with a code. And if we look back at that domain resource.text, we see, oh yeah, sure enough, it's got a value of, it has the wrong predicate, it really should be that, and then sure enough, everything validates. So what we have is effectively your standard schema language that allows you to test the structure and values and value sets, small value sets. So this allows us to validate data during production and consumption, as well as rapidly prototype data and schema for some particular problem domain. Here, for example, is a breast cancer ontology. Something like this. There's an ontology on the left in the represented in OWL and displayed in Protégé. So something like this ontology on the left can be realized as FHIR RDF data, and that in turn can be schema validated. That allows developers of the model to work with the example data, but capture their modeling decisions in human-readable schema language. So that's how we're using FHIR RDF to do effectively agile development by exchanging examples, testing them with schemas, and making sure that we are all talking about exactly the same constrained language. Thank you.